All right, so brief recap of that t-distribution. So a t-distribution is a sampling distribution with an estimated standard error. So in other words, based on S and not sigma. So when you're using only your sample standard deviation, you're using a t-distribution. And as long as you have a large sample size, it's the same as a normal distribution, so you can just use a normal distribution. But if it's not, it looks different. So if you have a large sample, it's normal, and that's where n is greater than 30. And it works the exact same way as a normal distribution, where you would take your sample mean, use it as your best guess, and then you can find your critical t-values instead of your critical z-values and plug them into a confidence interval formula. So your small sample confidence interval formula looks like this. Where you have your sample mean, whatever that is. I'm going through this quickly because I'm not actually going to make you do too much with it this week. You have your critical t-value, which is the exact same thing as the critical z-value, except it's based on the t-distribution. And the thing that's different here is that because the t-distribution changes shape based on your sample size, so when you have a small sample, so a sample smaller than about 30, you have a distribution that's kind of more flat and has these fat tails. And I don't know, I think that's funny, but I do. But that means that your critical t-values end up being different because you just have a different shape that you're working with. So unlike the normal distribution, where no matter what your sample size is, your shape of your standard normal distribution is the same, with the t-distribution, when you have different sample sizes, the shape of the distribution is different, which means that your t-values might fall in different spots. So the values that would be on either side of your interval or buffer around your point estimate end up being different depending on the sample size. So the critical t-value is something that you would look up, but it's going to be different depending on what the sample size is. Whereas when you're only working with the normal distribution, your critical t-value is only based on your confidence level. This one's based on your confidence level. And sample size. Then you have your sample standard deviation and your sample size. So with that, you could just plug everything in. So for example, in our last problem that we did where we had a sample of 40 police officers, if it was a sample of 20 police officers, instead of using this confidence interval formula where we have a critical z-score, we would use this confidence interval where we have a critical t-score. And we would look up the critical t-score for the t-distribution of the correct size and plug that in instead. And again, what that does is that counts for the extra uncertainty that comes from using a small sample to make an estimate. Because with small samples, there's just more of a chance that you're going to get some kind of strange or unlikely results. So just a brief recap here. If you know the population standard deviation, your confidence interval formula is going to look like this. X bar plus or minus z over your population standard deviation, times your population standard deviation over the square root of n. So that's if, for whatever reason, you happen to know the population standard deviation. If you don't know the population standard deviation, you have two options depending on your sample size. And you can use this one, which has a critical z-value, which is easy to look up because it's always the same for a particular level of confidence. And if you have a small sample, you would do this formula with a critical t-value, which is going to change more depending on what your sample size is. So depending on how small it is. All right, and in general, we're going to be assuming that any variable that you're calculating a confidence interval for is normally distributed. At least if your sample is small. But that's all I've got for you today. So key things to take away from this lecture are how to calculate a confidence interval, what formula to use when, and what a t-distribution is. Alright, so with that, I hope you guys have a great week, and as always, feel free to reach out to me if you have any questions about anything.